I, Tamanna Sharma, welcome you all to day 8 of 21 Days International Winter School Training Program. The enthusiasm, active involvement, and the thoughtful interaction demonstrated by participants over the past 7 days have truly enriched this academic journey and strengthened the spirit of collaborative learning. Each day of this program has been marked by meaningful discussions, valuable knowledge exchange, and interactive session that continues to broaden our perspective. As we step into the today's session, we carry forward the same zeal for learning, collaboration, academic excellence that has defined this winter school so far. On behalf of Just Agriculture and the Indian Society of Agriculture Science and Technology Research and our esteemed collaborative partners, I extend a warm welcome to each one of you to this international training program organized under the theme Revolutionizing Agriculture System through AI, digital tools, and green technologies. The Winter School serves as a global forum that brings together scientists, academicians, researchers, industrial experts, and policymakers. In the present agricultural landscape, AI driven innovations, digital tools, and green technologies are playing an increasingly crucial role in enhancing resilience, improving productivity, and ensuring farmers' welfare. As we commence the day 8, we look forward to another insightful and engaging session. Participants will continue to benefit from the expertise of renowned national and international speakers from countries such as USA, Canada, Australia, Egypt, and India, who will share both cutting edge research insights and practical field experiences. The overarching objective of this program is to build up capacity, promote innovation led agriculture, strengthen global academic cooperation, and translate scientific research into impactful real world solutions. We sincerely acknowledge and appreciate the valuable support for our collaborative institutes, VNMKB Parbani, UAS Raichur and Level University Canada, and ICAR NBPGR New Delhi, for this continued contribution to the successful of this initiative. With these words, let's proceed with our day 8 and this reaffirming our collaborative commitment towards building a sustainable, inclusive, and future ready agriculture ecosystem. So, ladies and gentlemen, it's my privilege to introduce our distinguished scientists whose contribution to the agriculture research, particularly in soil science, have profoundly impacted farming communities in Maharashtra's dryland region. Dr. Nitin Kumar Jagannath Ranchur serves as a chief scientist and associate director of research at the Zonal Agriculture Research Station under MPKV in Solapur, Maharashtra. With impressive 29 years of dedicated services in teaching, research, and extension at MPKV Rahuri, Dr. Ranchur has been a pillar of agriculture advancements. His work focuses on the challenging dryland areas of Maharashtra, where water scarcity and the soil degradation poses significantly hurdles to the farmer. Through the innovative research and practical solutions, he has helped in bridging the gap between the scientific knowledge and on the field of application. Dr. Ranshur's commitment to the education is evident in his mentorship. He has successfully guided 3 students to their PhD in agriculture, 11 students in masters in soil science, and these young scientists now carry forward his legacy, contributing to the nation's agricultural progress. As an accomplished author, he has published about 26 books, book chapters, and practical manuals tailored for students and faculty in the soil science. These resources have become essential tools, simplifying complex concepts and aiding helping hand for the students, learning for countless aspiring agriculturists. His most tangible impact lies in the farmers centric innovation. He has developed 11 technologies and recommendations, especially for the dryland farmers, addressing issues like soil fertility, water conservation, and sustainable cropping in rain fed areas. These practical solutions have empowered farmers to boost their productivity despite the harsh conditions. Additionally, Dr. Ranchoor has filed 6 design patents with the Government of India, protecting innovative tools and method that enhances agricultural efficiency. His excellence has earned him 26 awards, letters of appreciation, and recognition at the national as well as state level. A testament to his outstanding contributions, Dr. Ranchoor's scholarly output is remarkable. 59 research papers in NAS rated journals and 43 conferences and technical publications. These works advance knowledge in soil science and provides evidence based insights for the policy and the practices. Currently, he leads as a principal investigator for two prestigious national projects, NICR, that is National Innovations on Climate Resilient Agriculture, RKVY2, that is Rashtriya Krishi Vigyan Yojana. Vikas Yojana. These initiatives focus on building resilience against climate change and promoting sustainable development in vulnerable regions. Dr. Ranchoor has organized 26 conferences, seminars, workshops, exhibitions, and training programs fostering collaborations and knowledge exchange. He has actively participated in numerous international, national, state level events, staying abreast of global advancements. With that, I now invite Dr. Nitin Kumar Jagannath Ranchoor to share his valuable insights and thoughts. Dr. Ranchoor, the stage is yours.
Thank you very much, madam, for your kind introduction. Good
Sir,
evening to
your
all of
mic
you.
is not on.
Yes, it is on. Do you get my voice?
No, sir, you're still not audible.
Actually, my mic is on. It is showing on.
Okay, now, sir,
Hello?
you are audible.
Hello? Am I audible?
Yes, sir, clearly audible.
Okay, thank you very much, madam, for introduction. Good evening to all of you. For this lecture, I'm thankful to Just Agriculture for giving me this opportunity to discuss with you. So today, I'm just sharing my PowerPoints. Just a moment. Is it visible? Hello?
Sir, it's not visible yet.
Just I have shared it. Just a moment. I will again check it. Hello?
Yes, sir.
Can you see it now?
Sir, it's still not visible on our screen.
Just a moment. I will check it again. No, it's not visible.
Sir, it's visible now.
Is it visible? Is it visible now?
Sir, screen is
Can I see
visible, but the PPT is not there.
PowerPoint is not visible? Okay. I'm trying to share it. Some problem might be there. Just a moment. I will just check it. No, some problem is there.
No problem, sir. You can drop your PPT on the mail that I have shared in the chat box.
Okay. Just I will try it once again. Hmm. Hmm. Hmm.
Sir, have you sent the PPT?
Just I'm trying to send it.
Okay, sir.
Can you share your mail ID?
Sir, it is written in the chat box.
Just a moment. PSR SDK TPS. Just have sent it now. Please check it.
Okay, sir, I will check it out. Sir, I have received your mail. We'll be sharing in a while.
Okay. होते काहीतरी अडचण आहे त्याच्यामुळे.
Sir, you can start your lecture.
Hello, am I audible now? Hello.
Yes, sir. You are audible.
Okay. So myself, Dr. Nitin Kumar Ranshur. I am working as the Chief Scientist and Associate Director of Research at Zonal Agriculture Research Station, Solapur. Next one. So today we'll try to discuss regarding the soil-water interactions, because this is a very important topic. The students or the faculty that not from the soil science or from the agronomy, they must know what is the importance of these interactions, because all the nutrient availability, transport of nutrients from soil to plant, microbial population, all depends on this what we call as the soil water interaction, how soil and water interactions takes place. This is just I can say the basic concepts related with the soil water interactions, particularly to the students or faculty that are not from the soil science faculty, so that they will understand what happens actually in case of the interaction that will take place in the soil. Next, please. So today we'll try to discuss these three important points. First is what do you mean by the soil water potential? What is meant by the free energy and thermodynamics? Then basis of potential, that is concept of soil water potential and entropy of the system. This is we can say the basic material. If you understand the basic concept, then you can go for the advances in nutrient management or soil water management. Next one. So basically, when we say the soil water interactions, we must understand the what do you mean by the soil. One of the great scientists from Russia, Dr. he has defined soil as applied solely to those superficial or nearly superficial horizons of the rock that have been more or less modified naturally by the interaction of water, air, and various kinds of organisms, either living or dead. This being reflected in certain manner in composition, structure, and color of such formations. Where these conditions are absent, there are no natural soils, but either artificial mixtures or rocks. So this is a very concise definition, or we can say the meaning of the soil given by the Dokuchev. What he is saying that if the conditions are not prevalent, if there is no microorganisms, if there are no water or no moisture, then we cannot call it a soil. It can be called as artificial mixture of the rocks, but that are not natural soils. Next one, please. Next one. So if you come across, what do you mean by earlier one? If you want to see what are the, say, the good soils or good planting soils, so this is the basic, or we can say average composition of the soils. This is not exactly happens in the soil, but for good soil or good soil which give the good production, it should have average mineral matter about 45%. Organic matter should be about 5%. And air and water should be 25%. So this is the ideal composition. If such type of the ideal composition you will find, you will say that this soil is supposed to be very good, which will give good yield, which will give natural habitat to the organisms, and that is going to help for the increased production in the country. Next one. So basically, we can classify this into two parts. One we can call it as the volume composition and basis of the weight composition. Now, when we say the volume composition, uh, already we have seen that on basis of the volume, it is the mineral matter is 45%, organic matter is 5%, air is 25%, and water is 25. This is the volumetric content. But if you go on the basis of the weight composition, on the basis of the weight, we'll find that mineral matter matters about 85%. Organism is less than 0.1%, water is 12%, and organic matter is about 3%. This is the just comparison. Same content on the basis of the volume and on the basis of the weight. Next one. So as far as the soil science is concerned, or soil water interaction, because we know there are different branches of the soil science. So as far as the soil and water interaction is concerned, we are interested in the soil physics. As we have defined physics as the science that deals with the matter and the energy. A basic definition of the physics deals with the matter and the energy. Unless and until there must be some matter, and unless and until energy is transferred, that can be called as the physics. But if you see, if you want to define the soil physics, we can say that it is a branch of soil science that dealing with the state and movement of matter and transformation of energy in the soil. So just try to understand, it is the branch of the soil science that deals the state and movement of the matter. So in this case, we are discussing with the all things, means solid, liquid, and the gases, matrix, then water as the gases that takes place, and transformation of the energy. When the matter moves from one place to another place, energy transformation takes place. This is, we are dealing with the soil physics, and these are dealing with the, we can say, the soil water interactions. Now, what is the purpose of studying the soil water interaction? In case of the physics, it is to bring together the information on the physical property of soil and their effect on crop production. Next one. So these are the some of the basic property of the soil. Water will not go into details. Next one. Next. Next. Okay. So this is a very important diagram you can see. The recharging of groundwater depends on the water flow through the unsaturated vadose zone. Now, if you see this diagram, you will see that there are different zones in case of the soil, from soil surface up to the groundwater table. Now, the water that takes place to the roots, it's called as the soil water, or we can say the root zone. Below root system, that zone is called as unsaturated vadose zone. Below vadose zone, we will find the saturated, that is the capillary fringe zone, and at the end, we will find the saturated groundwater table. Now, at the base, you will have the groundwater table. Above it is the capillary, then a vadose zone, and above that, we'll have the soil water or root zone. So you can see the movement of water takes place from soil water zone to groundwater zone or saturated groundwater zone. It is the maintaining the equilibrium. Whenever there is a temperature increases, the movement of water takes place from groundwater to root water zone. And when we add the excess water, the water will move from the soil water root zone to the saturated groundwater table. So this we can say the movement takes place from top to bottom or from bottom to top, depending upon the condition of the soil and the temperature of the surface of the soil. Next one. So this we can say the interactions that takes place. How the this is not clearly visible. Just see the interaction of water by the soil. Now, if you see the top, you'll find that this soil water interaction takes place by, we can say, the three phenomena. One phenomenon is called the cohesion force. Second phenomenon is called the adhesion force, and next phenomenon is called as the surface tension. Now, the cohesion force you can see in the figure. You'll see that cohesion means a similar one. Whenever the similar particle attract each other, that is called as the cohesive force. Means water to water. We'll say that if you take a glass of the water, in that water, the oxygen is oxygen linked with one another. That is called as the cohesion. While the oxygen, when it related with the sides, that is called the adhesion. Means two process always takes place in case of the soil capillary reaction. At the side, the water stuck ups, that is called adhesion because it is a dissimilar. While in case of the water to water, this is called as the cohesion. This complete takes place in case of three forces. Last force is we called as the surface tension. The surface tension is the cohesive force among the liquid molecules are responsible for this phenomena. So we'll see details regarding that surface tension later on. But these three are very important parts of the soil-water interaction. That is called as the cohesive force, adhesive force, and the surface tension. So this will take place in case of the soil, capillary action, water movement, and the accumulation of the water in the soil. Next one. Then we come across another concept in soil science that we call as the soil water constant. Constant is mean that the value don't changes at all. Now we have different classification of the soil water constant. What is maximum retentive capacity? It is close to 0.1. Then if you see the next constant, that is called as the field capacity. It is about 110 bar for the light soils and 1/3 bar for the heavy soils. Then wilting coefficient, water is held at 15 bar. Hygroscopic coefficient, water is held at 31 bar. Then moisture equivalent. We should understand one relation, that is field capacity is equal to 0.86 moisture equivalent plus 2.6 wilting coefficients. Next, so they try to understand these are the values which are present in the soil based on the pressure, based on the attraction. We can have how much amount of the bar, how much amount of the pressure is required. If you see the field capacity, it should be 1/3 bar only. If you want to go for the permanent wilting point, it should be 15 bar only. So in that case, between field capacity and permanent wilting point, what we call as the available water. So we have the two different concepts: available water content and available water capacity. When we say the available water content, then it is a difference. But when we say the available water capacity, then we have to take into consideration the depth of the soil and the density of the soil. That will give available water capacity of the soil. So these are the fixed values in case of the soils. Next one. So you can see the movement of the water. First in the saturation figures, you will say that all pores are completely water and gravitational water is losing. This is the first stage in case of the soil. We saturated conditions. The next one we can call it the available water for plant growth, that is under the field capacity. You can see the blue color is the moisture, and last one figure that indicates the permanent wilting point. So no more water available to the plants in these three cases. So 100% moisture and no moisture. This figure clearly indicate how much water should be present at the field capacity. Next one. Field capacity is that capacity at which we have to carry out most of the operations before sowing. Next one. Next one, please. So again, we can classify the water, soil water, into different types. So for example, if you say the physical classification, physically we can classify water into three parts. That is gravitational water, capillary water, and hygroscopic water. Less than 1/3 bar, 1/3 bar to 15 bar, and hygroscopic water is more than 31 bar. This is the physical classification. You can see the figures also. Next classification can be called as the biological classification. In that case, we have the available water. Available water means water that is available between field capacity and permanent wilting point. That is called, I already told you, the available water content. And capacity, we have to go for the take into consideration density as well as the depth of the soil. Unavailable water, if it is more than 15 bar. And third more classification in case of the biology classification, superfluous water, water which is retained in the soil beyond the field capacity moisture tension. This is called as the superfluous water. So physical classification, then biological classification. So you can see the figure also, capillary water held by the particles. We can have the soil particles, and between these three soil particles, we'll find the capillary water. The black color that indicates the capillary water that is present between soil particles. Next one. Next one, please. So see, this is the, again, graphical representation, what we can call as the hygroscopic water. It leads to the wilting point. Remaining water adheres to the soil particles. If you see the particle, red in color, and on the boundary of the just earlier one, previous one. Previous one, this one. So see the red color dot indicate the particles. and to the boundary of the particle, you'll see a very blue line. That is the moisture under case of the hygroscopic water. Now, if you see the capillary water, you'll find that the blue color is going on increasing. That is called as the capillary water. The capillary water present between the microbes. And last one, we can say the gravitational water. You will see that the content is more and the water is draining through that. So you can see the diagrammatically, it moves from the filled capacity to wilting point. And between these two water, we can have the available water content. That is called as the capillary water. Next one. So again, this is the, we can say the potentials, how potential increases. So water remaining in soil after wetting and drying, you can say if we can classify into 4 parts: unavailable water, then plant available water, then gravitational water, and the flooded condition. Now you can see the unavailable water is called as the dry. It comes nearby the own dry. Then next we have the available water content and gravitational water content. It comes near the field capacity. And last one is we can call it the flooded conditions. So you can see this permanent wilting point where it is the line, the drainage takes place. That is called as the permanent wilting point. And next to this air dry, we can hygroscopic water. So water remaining in soil pore after wetting and drying is called as the hydroscopic water. So it increases from oven dry to saturation content. So you can see this figure very clearly from unavailable water to flooded conditions, saturation to air dry conditions. So this is the moment of water takes place when you add the water or irrigate the soil. It is called as the saturated. From saturated, it is going to filled capacity. From filled capacity, it will go to permanent melting point, and from permanent melting point, it will go to own dry condition. These are the potential that are present in the soil. So at the flood condition or saturation, you will find it is a 0, 1. While at the field capacity is 1/3 bar, at permanent melting point it is a 15 bar, minus 15 bar. So 100% saturation means no tension. While it goes from the 100% to saturated to unsaturated condition, the tension goes on increasing. Next one. So this is the we can call as the energy state of the soil water. What energy is required? The capacity of the doing work is termed as energy. We know it very well. Energy we have defined, we have learned during our 12th standard in case of the soil science students. Energy, it is the capacity to do work. And we can calculate this energy. We have two types of the energy. One is called the kinetic energy, another is called as the potential energy. The kinetic energy, we know that it is the ability to do work by the virtue of the motion. But as far as we can say the soil science is concerned or agriculture is concerned, we are interested in potential energy. What is the potential energy? It is the amount of work done or energy stored in bringing any body of mass from the reference point to the point of questions. So we have to fix one standard reference. And from that reference, how much amount of the work is required? Just a moment, one call is going on. Please, hold on. Sorry, there was a very important call from the university. I'm very sorry for it. So we are discussing regarding the energy status of the soil. So we know that there are the two types of the energy. One is called as the kinetic and another is called as the potential. And as far as the movement of water in soil is very meager or very less, I will not take into consideration the kinetic energy, because energy due to the state is a potential energy. That is that the root system. That's why we have to take into consideration potential energy. Next one. So see these different types of the potential. Uh, Potential means capacity. It was introduced by 1907 by Buckingham. It applied to describe water energy status or ability to work. At equilibrium condition, water has the potential to do the work, and the energy associated with potential energy, or the briefly is called as the potential. So this actually takes place the equilibrium, means movement of water. Potential means what is the capacity, and the energy movement takes place from the higher concentration to the lower concentration. So if you apply water at one place, it will move from one place to another place. That is called the potential, and this will movement will continue till the equilibrium attains. And it is the sum of the contribution of various forces acting on the soil, water, such as metric, osmotic, and solid potential. So, in case of this, when we say the potential, there are different types of the potential. We'll see the different types of the potentials also. Next one. Next one, please. So isothermal conditions, the earlier one. So we can have the, if you see the potential, it is a combination of metric potential, pressure potential, and the atmospheric potential. So very important part in this case is this potential can assume a positive or negative value depending on force acting on the soil water. We'll have the positive as well as the negative signs also. We'll see that regarding this different types of potentials also. Next one. Next one. So, see, just earlier I have discussed regarding the positive sign or negative sign. So, the presence of the solutes and matrix component decrease the capacity of water to perform work. If the solute goes on increasing, or if your matrix content, means solid material goes on increasing, the capacity will go on decreasing. Hence, under normal field condition, the soil water potential will be always negative. So, this due to the content, solute and the matrix. However, under condition for which the hydrostatic pressure is greater than the atmospheric pressure, that is pressure plate, the potential will be positive. The metric potential perhaps the most important component is unsaturated soil. If the soil is unsaturated, means no moisture content, only solid particles are there, then it is called as the important concept. Whereas the solute or the osmotic potential significant force in saline soil amended fertilizers and the organic wastes. So when the soil is saline conditions, then it is important to have the solute or osmotic potential. Next one. Next one. So these are, we can say, the different types of the soil water potentials. We can say the gravitational potential, pressure potential, metric potential, osmotic potential, submergence potential, pneumatic potential, and the overburden potential. These different are associated with the component of the soil water. So we'll discuss this one by one. Next one. Next one. So what is the total soil water potential? The total soil water potential defined by the International Society in terms of the physics is saying that the amount of work required to transport reversibly and isothermally an infinitesimal amount of water from pool of pure water at a specified elevation at atmospheric pressure to the point under consideration. So we have to fix some standard. What is the standard? It is the pure water. And from that pure water, how much quantity of work is required to transport the water? That will determine the potential. These potential include the water potential and arising from the external forces of the fields. Which forces are acting on the soil? That will determine the different types of the potentials. So any system can have the standard, and we have to compare on the basis of the standard whether the potential is more or whether the potential is less. So we can assign the positive sign or negative sign on the graph depending upon the standard conditions. Next one. So we can have this total potential. It can have the mixture of the or addition of the water potential, gravitational potential, or any other potential arising from the external field. Since in soil, gravity is often the only external force field of the importance. The total water potential is expressed as, see, earlier we have written the total potential as the water potential, gravitational potential, and the other potentials. Now, when the gravitational condition exists, then we can write potential as only water potential and the gravitational potential. So in that case, we are not going to consider any other forces acting on that. Next one. Someone has shared the screen. Hello. Someone has shared the screen. Neha Singh, please remove your screen. Tamanna madam. Hello.
Yes, sir. We are checking it out.
Some participant Neha Singh, she has shared her screen.
Sir, we are sharing the screen again.
Okay.
Sir, you can start.
Okay, next one. Earlier one. Earlier one, please. Previous one. Earlier one. So we already discussed regarding these two conditions. One is the water potential. We will take into consideration the other potential. While in case of the, if it is under gravity, then we can consider only water potential and the gravitational potential. Next one, please. So this is the metric potential. It is written as a psi-m. This is very important part in case of the unsaturated soil. We already seen. So what is this metric potential? It is the attraction of soil solid. Particularly, it is called as the matrix. Soil solid is called a matrix for water. So when there is attraction takes place between soil solid for the water, that provides the metric force, and that part of the water potential distributed to the matrix force is called as the metric potential. So matrix potential is related with the soil solids. So in the presence of the soil particle, water is subject to adsorption on the particle surfaces, and adsorbed water cannot move freely as the free water. So this water is adsorbed. We know there are two types of the phenomenon. One is the adsorption, another is the absorption. Adsorption is the surface phenomena. Attraction takes place. We already seen there regarding the what we can say the dissimilar forces. If it is a similar forces, we call it as a cohesion. If it is a opposite forces, then we call it as adhesion. So in this case, adhesion takes place. Adhesion means water that is attracted toward the negative signs of the clay particle. That is called as adsorption. So if you want to determine the metric potential in the soil, we have to place the tensiometer. One instrument named as the tensiometer can be fixed into the soil. That will determine how much amount of the metric potential present. So we have to fill that tensiometer with the deaerated water. We have to fix it into the soil. So as soon as the water from the soil is lost, the movement of water takes place from the tensiometer to the soil. So and we'll note the reading. And we know that we have to apply the irrigation at 0.8 bar. Before that, the tensiometer dysfunctions. So it will determine this can be used for the criteria for scheduling irrigation. If you want to go for at what we can say bar, we have to schedule the irrigation. In that case, we have to paste the tensiometer into the field and we have to determine the metric potential. Next one. So in saturated soil, we will see that we already seen the metric potential is 0 because there is no at all tension. This 0 is related with the tension. If it is completely filled with water, it will have the 0. If it is unsaturated soil, then we can have the negative. Metric potential and metric suctions refer to same property but take opposite signs. So we can say the sign. It is very simple. We can compare with the what we can say the balance. Whatever the more balance in your account, bank account, then you don't have the tension. That means your tension will be zero. If you withdraw money from the bank, what is going to happen? Your tension is going to increase. That means in that case, it will go on increasing. So that is the condition. In saturated soil, moisture is too much. So no tension. If it go for a saturated to unsaturated, the tension grows on increase. That's why we give it a negative sign. Next one. So another potential is called as the pressure potential. So pressure difference is resulting from air or pneumatic pressure of the atmosphere. So one important part is the in saturated soil, the pressure potential is greater than the atmospheric pressure. Try to understand this very important part. If the soil is saturated, the pressure potential is always greater than the atmospheric pressure. In case of the water under unsaturated soil, the pressure potential equals the zero. Since the liquid or water pressure can be neglected, where the soil pressure can be considered equal to that of the atmosphere. So in the case where atmospheric pressure and the soil pressure is, we can say equal, that's why it's zero. So negative pressure potential occurs only when soil water is subject to pressure lower than the atmospheric pressure. So this also should consider when the pressure potential will be negative, only when the water is subjected to pressure. How much pressure it should be lower than that of the atmospheric pressure. That is called as the negative condition it will create. Next one. Next one. The now next potential is called as the osmotic potential. Now this portion of the water potential attributed to attraction of solutes. That means ions or other molecules or water by osmotic forces called as osmotic potential, and sometimes it is called as a solute potential. So osmotic potential is related with the weaken the solute content, salt content, ionic content. That potential is called as the osmotic potential. This potential becomes important only if the semi-permeably present. We know what is meant by the osmosis. Osmosis movement of material from one place to another place in presence of the semi-permeable membrane. So solid particle we move from one place to another, from higher concentration to lower concentration through, we can say, the semi-permeable. That is called as the osmotic potential. It is act as a barrier. In the absence of the membrane, the solid will flow with the water and equilibrium will maintain. Next one. So we can write it as the pi is equal to MRT. Total molar concentration, temperature, and the gas constant. Will not go into detail. Next one. So see, this is what I already told you regarding osmosis, osmotic potential. A movement will take place from a semi-permeable membrane from higher concentration to lower concentration till the equilibrium attains. Next one. So another one is we call as the gravitational potential. Now, gravitational potential is the portion of the water potentially attributed to downward pull of the water by the gravity. The water movement takes place due to gravitational forces from one place to another point, and the gravitational force takes place. The amount of work needed is stored in the water in the form of the potential energy. We have already discussed. See, two figures I have shown here. One is the potential energy. In energy due to state, it will not move. It will stay at one place only. As far as the agriculture is concerned or soil science is concerned, we are interested in potential energy. But in second figure, you will find the kinetic. It is movement. Moving takes place. When in case of the, what we can say, the soil, movement of the water is very, very less or negligible. That's why we are not taking into consideration the kinetic energy. We always think in terms of the potential energy. Next one. So these are the some of the formulas regarding that. Will not go into detail. Next one. Please, next one. One more potential we call overburden potential. This potential is caused by weight by overlying matter pressing on the soil water. If you add some material onto the soil, then it's called as the overburden potential. One important potential is called as the pneumatic potential. The pressure potential also includes the effect of any external gas pressure or other than atmospheric pressure. Now, what is the external gas pressure? That will give you the pneumatic potential. If there is a difference in gas pressure between the reference pool and the soil, the liquid pressure is measured at these 2 points will be affected by amount that is equal to difference. Thus, the pressure of soil water may also be affected by change in the pressure of the ambient air. This change in water pressure due to potential is called as the pneumatic potential. Now, the potential that takes place in the soil due to water pressure, that due to gas pressure, that is called as the pneumatic potential. Next one. Next one. One more potential, which is called as the submergence potential. The positive hydrostatic pressure of water table reference to the surface of the free water or water table where water is atmospheric pressure. You can call it as the P is equal to rho GH, where rho is the density of the water, acceleration due to gravity, and submergence depth. This will totally give you what we call as the submerged potential. And to measure the submerged potential, we can use the instrument called as the piezometer. So, if we want to measure the submerged potential, we have to take into consideration density of the water, acceleration due to gravity, and submergence depth. Next one. Next one, please. These are all basic concept. Next one. This is the only unit we can say. Okay. Tamanna madam, how much time do we have? Because another topic we have to start with. Just I am explaining the pure concept to the students other than the soil science or other students who are not aware with these concepts. Tamanna madam, can you continue further?
So you still have like 10 minutes.
Okay, okay. I will just try to hurriedly complete because these all are the basic concept or basic term that most of the students don't know. That's why I want to clear these things to them. So, in case of the thermodynamics, what we call as a system. We have already heard the government system or any sort of the system. So in case of the science, what do you mean by the system? It is a portion of the universe that is selected within the definite boundary for an investigation. For example, if you take the, we can say the any agriculture land, and if you take only one patch of the soil for the study, then it is called as the system. It is a portion that we have taken within the definite boundary for the investigation. And then what is the surrounding? The part of the universe other than the system is called the surrounding. Earlier, we are dealing with the system, and next nearby the system, that is called the surrounding. Next one. So there are different types of the system. We can call it an isolated system, closed system, or the open system. A system is said to be isolated if it cannot exchange matter energy within the surrounding. Means when there is no exchange of matter or when there is no exchange of the what we can say the energy takes place, that is called as isolated system. Another system is called the closed system. A system is said to be closed if it is an exchange energy but not the matter. An open system, a system is said to be open if it can exchange matter and energy with its surrounding. So our soil is called as the open system. Because in this case, we are not dealing as far as the agriculture is concerned or soil science is concerned. We are not interested in isolated system. We are not interested in closed system. We are interested in open system. So we can have the exchange of the matter and we can have the exchange of energy within the surrounding. That's why we call the soil as the open system. Next one. Next one, please. So boundary, there are different types of the boundary, imaginary boundary, rigid boundary, or we can say the adiabatic boundary. Next one. So these are the different functions we can say state functions and the path functions in thermodynamics. When a system changes from one thermodynamic state to another thermodynamic state, the change in the value of the variable depends on the initial and final states and not on the path of the process, along with the transformation we carried out from the initial state to final state. So we can have the pressure, temperature, etc. While in case of the path functions, there are some thermodynamics quantities that whose value depend on the way of the transpiration of the system and are called as the path function. So what is the heat and work that come under the path functions? So in this case, its value depend on the way of the transformation in the system. We'll have the discussion on this if time is possible. Next one. Next one. So what are the different processes? Earlier one. So process, what is the process? The process is a, no, next one. Next one. So what is the process? Process is the path along which the change takes place. That is called as a process. So we have seen the system, we have seen the surrounding, we have seen the boundary. Now we'll see the, we can the process also. What are the processes? So different types, isothermal, isobaric, isocrocky, adiabatic, cyclic, reversible and irreversible. These are the different types of the process that takes place in the soil system. So we'll see also if time permits isothermal, what is that? Isobaric, isochoric, adiabatic, cyclic, reversible and irreversible. These 7 types of the process always takes place in the soil. Next one. So what is the thermodynamics? Thermodynamics is the branch of the physics that deals with the heat and temperature and the relation to energy, work, radiation, and properties of the matter. This very important part. When thermo means the temperature and dynamics means the changes that takes place. So how much the temperature or heat that changes from one part to another, what capacity is carrying out, that is called as the thermodynamics. And this is a very important phenomenon in case of the soil science or in case of the agriculture. Next one. Next one. So one scientist called as the zeroth law, he has given the thermodynamics law. The zeroth law of thermodynamics states that if the two thermodynamic systems are each other in thermal equilibrium, with the third one, then they are in thermal equilibrium with each other. Means if A, B, C, if you see, if they have the energy, status same energy. If A is having the same energy, if B is having the same energy, if C is having the same energy, or then it is called as the equilibrium system. Equilibrium means what? The energy of the 2 points must be same. That is called as the equilibrium. Next one. So this is the, we can say, the first law of thermodynamics. Energy cannot be created nor be destroyed. We know it very well. It is also called as the law of conservation of energy. So another one is the total amount of energy in nature is constant. And we also know that the where quantity of energy one use up, an exactly equivalent quantity of energy of some other kind is produced. So we can have this, we cannot create new one. Whatever the energy is there, it can be converted from one form to another, and total energy in the universe remains constant. Next one. Next one. So you can see these two diagram. First law of thermodynamics, energy transformation. If you see the energy before and energy after, just critically it indicates that the energy is moved from one place to another, and equilibrium is attained. The arrow or the equilibrium scale given by the red arrow, it indicates that at the both the stages energy is same. Means movement takes place from higher energy to lower energy, indicating it is a zero. Means energy at the bond is both end is same. Next one. So law of conservation of energy, it is also known as Q is equal to delta mu plus W. It absorbs internal energy. Next one. The second law of thermodynamics. The second law of thermodynamics states that the energy transformation through physical and chemical process takes place in natural direction. Means it takes place only in natural condition. You cannot make it artificial. That is the direction in which they take place spontaneously. And the law specifies that the direction of change in isolated system is always toward equilibrium. So if you see the figure, from hot, it will go to cold. From cold to, it will not go to the hot, because it is not going under the natural conditions. The total amount of entropy is increasing in this case. So figure itself indicates a very clear figure I have given regarding the second law of thermodynamics. Next one. So this is a very important concept called as enthalpy. So most of the students are not aware about this term. It is the heat content of the system. Enthalpy is nothing but the heat content of the system. So it is the sum of two energy associated with the system, namely internal energy and another energy. So H is equal to UPV. We can go for the enthalpy. Next one. So another term that is related with this system is the entropy. So what is entropy? State property that helps understanding the condition of the system. So what it indicates, it is the measure of the degree of randomness or disorder in the system. Means when the system is not in the order, when it is haphazard takes place, when the disorder takes place, that is called as the entropy. The entropy of the universe increases when there is a spontaneous natural change takes place. So it can be indicated by delta S. So change in enthalpy divided by the temperature. Next one. So another concept that is called as the Gibbs free energy. This is also called as the Gibbs function or thermodynamic potential or free energy. So G represents the amount of energy that is actually available in the system for doing useful work, and is equal to enthalpy of the system minus the product of the temperature and the entropy. So you can write G is equal to Gibbs free energy is equal to H minus Ts. H is the enthalpy, while the change in the Gibbs free delta indicates the change in energy is equal to delta H minus T delta S at the constant temperature. That can give you the Gibbs free energy, change in the Gibbs free energy. Next one. So thank you very much. Just I will try to finish within 1 hour. Lots of things need to be discussed because due to paucity of the time, just I want to uh, discuss with the students or participants the basic concept related to the soil water interactions. Thank you very much. Thank you, Padamana madam. Hello.
Yes, sir. Thank you very much, sir, for explaining everything so nicely. The entire was so clear and systematic. There was lots of new thing that I also learned, and I really appreciate the efforts and the clarity you have brought to this discussion. Like to tell the participant, like if you have any question, you can drop in the chat box. So the questions are there in the chat box. You can answer them.
One question I'm saying that why does the free energy that one now? One important question I want to just why capillary water moves upward in the soil against the gravity? Okay, this is important question I want to say. Hello. Hello.
Yes, sir. So you can answer them.
Okay. See the free. One more question I have just seen that I need to answer. Very important technical question.
So you need to answer the questions which they are dropping in the chat box.
Yeah. I'm just got some problem with the net. No, just I'm seeing that. Just a moment. Mhm. Mhm. Okay, one question is why does the free energy decrease in soil water moves from the surface to subsoils? Because the whatever the solute or material that added into soil that absorb the energy, that is the reason. So absorption of the energy that decreases the we can say the soil content is at the topmost. Then why it absorb the energy and it goes on decreasing. One important part is the why does the capillary water moves upward in the against the gravity. So a very important part is that the movement takes place from higher concentration to the lower concentration, right? So moisture content is higher at the subsurface level, and as the temperature increases at the surface level, what happens? The moisture is evaporated at the surface due to increase in the temperature. When the moisture at the surface is lost, automatically the moisture at the surface, subsurface is coming at the top. That's we call as the moment, higher concentration to lower concentration. That is the reason only the capillary rises takes place. Next one.
So there are more questions.
Yes, I'm seeing that. I'm just saying that. I'm just So how much the structural? No, no, actually, in case of the puddle soil, this is the one question. In case of the puddling soil, we are making the base stronger at the base. That's why the macropores need to be maintained, and it helps in the redox potential and the oxidation potential. That is the reason we should take into consideration the as compared to the undisturbed soil or natural soil. The undisturbed soils are the oxygenous soils, while in case of the puddle soils, we have to compulsory make it the what we can say the compactions, so that the water should not be lost. Next one. Why some plants are not able to absorb the water from soil when there is already sufficient water available? It might be due to the salt content. If the salt content is more, then there might be some problems regarding the absorption of the water, because the property of the salt is to absorb the water, and that's the content can we can say the changes the absorption of the water. Particularly related with this, what we can say the solute content or salt content. Sir, why we measure the different potentials? So what we are interested in, we can say metric potential we are interested. We are interested in the available water content. That's why we have to measure the potential. So for example, field capacity. What is the potential at the field capacity, and what is the potential at the permanent melting point? So how much water is available for the growth of the plant? That is the reason we have to measure the potentials. Particularly metric potential is very important. As far the other potential is concerned, that can be used for research purpose. Next one. Okay, anything more? I think I answered most of the questions. Actually, just I want to give the concepts of the soil physics. Not really just I have lots of data to share or support with the staff or students, but I think that most of the participants are from the other disciplines, and they should have the knowledge of the basic concept of soil. That is the reason, nothing else. Thank you.
Thank you once again, sir. That was really a nice discussion, and thank you being a part of this program.
Thank you. Thank you. Thank you. Thank you very much. Thank you very much. Thank
Yes.
you.
So it
Shall I?
is truly a privilege. Sorry, sir.
Yes, yes, continue, please continue.
Use our next team speaker of today, Dr. Shirish Yograj Khedkar. Dr. Yograj Khedkar is a dedicated scientist at the Indian Meteorological Department in Pune, under the Ministry of Earth Science, Government of India. Holding a PhD in agriculture meteorology from TNAU, he specializes in agrometeorology, focusing on climate variability, weather forecasting, meteorological data analysis, and their impact on crop production, productivity, and environmental sustainability. In the face of climate change, challenging, threatening Indians' food security and farming communities, his research provides critical insights, including the studies on the rainfall variations, the effect on the crop like tur, cotton, maize in the regions such as Maharashtra and Tamil Nadu. Trends on surface ozone concentrations across the Indian cities, crop weather relationship for improved forecasting, and the application of extended range forecast system with the tools like DSSAT models. Beyond research, Dr. Khedkar is an exceptional innovator who set a national record by filling the 10 patents application in a single day on March 30, 2020. Amid the onset of the COVID 19 lockdown, an achievement recognized in the Limca Book of Records 2020 to 2022 and the Indian Book of Records. His environment friendly inventions, often inspired by the natural elements like sky, air, water, fire, and earth, includes practical solutions such as solar trackings, panels with the built-in LED lights, a microclimate control mosquito net, and automatic water level detection device, multifunctional portable electronic devices, and altitude recorder and dual axle tracker and wind elevation angle recorder. He holds multiple patents aimed at efficient renewable energy harnessing and sustainable everyday problem solving. An active member of Indian Meteorological Society Pune chapter, Dr. Khedkar contribute to professional discussion, knowledge sharing and outreach. His journey from passionate researcher to the record holding inventor exemplifies the power of science, innovation and perseverance for the societal benefits. And with the heartful gratitude, I welcome you, sir. Now you can take the platform.
Yes. Thank you very much. Then just agriculture and for nice introduction. I think it was bigger than what I deserve. Okay. So without wasting my time, shall I start presentation?
Yes, sir.
Tamanna Sharma madam, thank you very much. So shall I am starting my presentation.
Yes,
Okay.
sir. So you can continue.
So is it visible?
Yes, sir. It's clearly visible.
So today's topic is innovation is a key to success for agriculture in India. Okay. So these are the pathways to productivity, resilience, and farmer prosperity. So what is this slide? Okay. So why? Okay. Wait, okay. So here, why innovation is critical? Because why we require innovation was most important thing. Because in India or entire world, there is a continuous rising the food demand with the limited natural resources, climate change. Okay, it's on our doorstep. Increasing weather variability, need to double the farmer income because already government of India they decided that they want to double the farmer income. Then shifting from input intensive to knowledge intensive farming. Okay, so why innovation matter? Because for increasing food productivity and to close yield gap, we require innovation. Effective use of water, fertilizer, and energy, then climate resilience, risk reduction, higher farm income, and rural employment. So for all this, we require because this is not possible without innovation, we cannot sustain. Okay. So key challenges for Indian agriculture are small and fragmented land holdings, water stress and inefficient irrigation, low mechanization in many regions, market access and post-harvest losses and climate change already there. So why innovation in agriculture important? Because we have challenges like small land holdings, water scarcity or independence on monsoons, post-harvest losses. Okay, then opportunity. What opportunity we have? Improved farming income through value addition, address challenges of rural electrification and climate change. So these most of the things now rural electrification is already done. Then organic farming. So what we already having the organic farming and sustainable farming. These are the already we were having, but due to under construction means under the modification of greenhouse green I think say green revolution, so these we left it. So promo now again there is a chance, there is a good opportunity that we already having the experience. The organic farming we already was Indian was doing, and these the western I can say world was following us. Now they are adapting and we are still need to adapt. So like we have the best example like Bhutan. They very small country or even Sikkim like that, very small states in northeast. They are adopting the this green so organic farming. Okay, so it is possible for us also. So there's so importance of innovation in agriculture entrepreneurship because this will help to increase efficiency, climate resilience will there, economic empowerment will be there, and market competitiveness. Okay, so for innovation we require. So some case studies are there like Amul. They have some innovation like they prepare their cooperative model. Okay, so then case studies like here Eureka Technologies, they use IoT based aquaculture solutions It's not depend on entire thing we can cover. We can cover small part of problems. What the problem they found, and they how the solution they prepared for them. Then this is Star Lab Technologies. Okay. So dairy IoT based platform addressing the entire dairy supply chain, because in dairy, because it's a running item, and as it we cannot pack the milk every place, because milk is there is a high chances of adulteration. We before giving final to the end consumer, that time only we are packing the milk, but entire from dairy till plant, entire there is a chance of adulteration. Okay, so automatic milking system, milk analyzer, so this innovation can be done there. Then where here one solar powered cold storage is there, UP Bihar. They did some innovation, like because cold storage is most energy consuming, you can say, mechanism, because they require continuous power supply. So that can be done by solar. Okay. Then one more innovation like rotary disc. Okay. So then patent for e-crop IoT device for smart farming. So these are some examples. But what are the challenges in agriculture innovations and patents? So filing cost in India, some might be less, but in other countries, it's a very high. Okay, limited access to the fund for small scale innovators. Lack of awareness. Farmers are unaware about patent benefits and procedures. Sometimes you found that they think that it is innovation, but that might not require, it may be copy from somebody. Okay, so fragmented land holdings, okay, difficult to implement the large scale innovations, like large scale harvesting, not possible, because they have small, I can say that small, for example, rice, they have very small like fields. Okay, so regularity bias. So sometimes approval process of patent is also very long. Okay, so then government schemes supporting the agriculture innovations like Pradhan Mantri Krishi Sichai Yojana, Pradhan Mantri Krishi Vikas Yojana, Startup India, production of plant varieties like PPVFR. So these are some. Then step to promote innovation in agriculture like farmer training, public-private partnership, subsidized patent filing, then R&D hubs. Okay. So government already doing like a small scale innovators, they are giving like startups, they are giving the discounts for the patent filing. Okay. Then future trends in agriculture innovation like AI and machine learning, vertical farming, blockchain technology, renewable energy solutions. Okay. So the major innovation domains like farm level technologies, then digital and data driven, supply chain marketing, finance, and policy. So from farm to the policy making, we require innovations can be done. Like recent agriculture innovations already AI, precision farming, IoT drones, automation, robotics, climate resilient seeds, genomics, sustainable and bio input innovations, digital marketing, finance, policy technologies, farm level technologies already I told them. Okay, then what are the impacts? So you can say compared to traditional micro irrigation can give more yield, and water use efficiency compared to flood irrigation, drip irrigation, we are save the water. So AI based data driven agriculture. Okay, so they are multilingual AI chatbots for farmers, predictive analysis for yield and irrigation planning. Okay, then precision agriculture like drone based crop monitoring, nutrition assessment, soil moisture. Then digital agriculture and data synthesis systems like satellite based mobile advisory, IoT based, then e-market, then supply chain and market innovations. There already we discussed how one stall in Tamil Nadu they have invented. Okay, so supply chain based farmer produce organization can come to help the farmers. Okay, then supply chain market like vertical farming. Okay, control environment agriculture, biotechnology. Then some mechanization of farm level solutions like farm robotics, automation tasks like planting and harvesting and reduce labor demand. Like farmer innovation solutions like tree scooters, might be you have seen somebody by farmer, then do by farmer. Okay, then digital platform apps like SBI, Krishi, offering integrated service to finance input and market access. Then reduce post harvesting losses, loss of percentage here. without cold storage and with cold storage. So then finance, digital credit, crop and weather indices, then climate resilient seeds and genomics like new drought and heat and flood tolerant varieties, short duration crops, improved seed distribution system. Here also in seed distribution, there is a huge demand for blockchain. Okay, how the seed is produced in the farmer and it is going to another farmer. One field where seed is produced, where the farmer requires seed. In between that, many times either seed will get adulterated or seed may be changed or sometime old seeds are given. So there is a huge gap, okay, that can be filled. Then water energy resource innovations like solar powered irrigation pumps, smart irrigation system, hydrogel, okay, water retention materials, groundwater monitoring and research solutions. Okay, sustainable like biocontrols, biofertilizers, biopesticides, nanotechnology, irrigated pest management, neutral farming, okay, natural farming and regenerative agriculture. Then digital marketing like Enam. Government have did some Enam like a digital marketplace, okay, cold chain, blockchain technology and direct farming to consumer. UPI is one of the, you can say, innovation because here significantly helped the Indian farmer by enabling instant and low cost digital payment. Previously, from transferring payment from one person to another, either they are in cash, they may farmer are not getting. May so here due to UPI, farmer and producer, purchaser directly getting some time without any middleman. So leading to greater financial inclusion, transparency, efficiency of transfer with wages and produce of sales, fostering the shift toward the digital literacy and farmer economic participation. So UPI is one of the, we can say, innovation that help the farmer from producer to seller. Even the person who is selling the agriculture goods, he is also previously entire it was cash oriented market. Now it is a cashless economy. Okay, these are some benefits. Then comparative innovations breakthrough in Indian agriculture, like satellite based, how crop management mainly for 15 to 25% yield is can be improved. So there it is impacting the water fertilizer reduction, adaptation rate is 30%. So some notable innovation like Farmanout and ISRO Bhuvan portal are there. Then AI and machine learning, then automation of robotic machinery, then smart dairy farming sensors, biofertilizers, blockchain based. So these are some technologies continuously coming, and there are these are the notable examples like brand. So then case studies highlighting already we did it. Then 5 year plan. So these are the 5 year innovation like pilot projects for training, then scaling the proven technology, then integrating the market finance, and then um, consolidation and means entire then nation rollout. Means first our entire technology we have to bring to one place and then national rollout. Okay. Then key performance indicators like increase the crop yield, water saving, farmer income increase, reduce the post harvest losses, and number of farmers digitally connected. So these are some key indicators we have to roll of startups and private sectors like AI advisories, then data analysis startups, agri logistic and cold chain companies, input as well as service business model, earth observation and satellite. Okay, so policy and government initiative like digital public infrastructure for agriculture. So last time, Government of India, the National Agriculture Innovation Project (NAIP) had total budget of around 1344 crores, jointly funded by World Bank and Government of India, implemented by ICR 2006 to 2014 to modernize Indian agriculture through innovations and partnership with almost 100% fund utilized for research technology and livelihood security in rural areas. Trainees, do you can you give answer that they have given the awards best innovation in India? Anybody know this? Which award was this? To whom this award got? Can anybody answer? Trainees, you can write in chat box also. Can anybody answer which award they got? Which innovation they got this year award for this National Agriculture Innovation Project? Okay, leave it. I will tell you. Ha. So I will tell you. They they given first award to veg sav and second to fish paneer. Veg sav was just one sprayer which you have to spray on the tomato and increase the shelf life. Such hundreds of already available in market. And okay, leave it. First is okay, we consider. Second award they have given to fish paneer. Just adding the fish pieces in the paneer. So can you imagine they have wasted 1344 crore and they have given best innovation award to fish paneer. One is veg sav and another fish paneer. So what a level of innovation was there in India during that time. Or might be, I don't know why they have given to fish paneer, just adding the fish pieces in the paneer. This was done by our grandmother and great grandmother, might be already, if she is a non-vegetarian or eating the fish. Adding a paneer in the fish was references found in the Rabindranath Tagore book. Okay, so what a wasting these types of money for in the name of National Agriculture Innovation Project. Okay, it was published in the news. It's not my word. Like called as veg sav, and another is fish paneer. Okay, so this was the wasting of the money, government money, just got money. I don't know why they did it this, but leave it. Okay, so this entire news was published. So we are not asking them where this amount is wasted. If you give 1 crore to one farmer, he will produce 100 of innovations in his farm. Simple 1 crore give to one farmer or 1 lakh to each farmer give. Thousands of innovation will be formed. Millions, not thousand. But they wasted how much amount? And what they invented? Two things, veg sav and fish paneer. What is this? Okay. So then recent innovations like in other countries like next generation agriculture technology, NextZat. Here the multi-faced machine capable of handling every steps in the crop production. Means everything from planting to harvesting to irrigation and to everything will be in the one device can do everything. Okay. Then another invention here, a real-time map showing areas of risk of soil compaction, where the soil is getting compact, that so that we can do irrigation and we can do some tillage or anything. So that is also one system is there. Then radiate next. So here supercharge the plant energy conservation, enhancing the both root and shoot systems. So that is radiate next agriculture biotechnology. So it is a supplying the nutrition, okay, fertilizer supply, boosting the resilience against the extreme weather condition. Whenever they require particular nutrition, they can be managed. Then Dimitra, that is blockchain agri-tech solutions. Here, combining the satellite image, AI, and other technology to offer the farmer tangible insight for smarter decision making from automating shipping and documentation. So it's one blockchain. Then VB, it is for combine data from the various sensor and extreme external sources like weather forecast for the benefit of agriculture. So giving the farmer. Then RoboVeg robotic. Okay. With robotic, that is robotic arm that pick broccoli quickly and efficiently. So broccoli cultivation, they one robot. Another is Kibuto, Germany. They have prepared one automated fruit picking system. Then this is agro conticil system. Okay. So here they did quickly and efficiently test the livestock for liver fluke directly on site. Liver fluke testing, the device, this means app they have prepared. Okay, so if cattle's getting these types of liver fluke, then they will get identified. Then conclusion and call for action. So innovation is no longer optional. Collaboration between government and private sector and farmers is required. Okay. Focus on scalable affordable and climate smart solutions, transform agriculture into profitable and resilient sector. Then some innovations did by me. So with permission of organizers, shall I show these innovations?
Yes, sir, you can.
Okay. So street light you are already knowing. Okay. So usually mounted on the poles and construct for one of the serious places where series of places where into a public street. Okay. So the problem of existing. So here are problem like faulty lights, electricity step, unnecessary uses, one size fit for all approach, no proper maintenance. Okay. So this was problem was exist. So these are what are the advantage of solar? No power required, no electrification required. Okay, no non-renewable sources required. Okay, then limitation. What was the limitation? High maintenance cost was there. Okay, acid batteries. Some people are putting the cloth on the panels. Then bad quality product was there. Then dirty panels, huge size of solar panel. Okay, then stealing of batteries was there. Batteries stolen. Okay, understood? No battery is there. Then damage of wiring, shock is possible. Then solar panel wrong direction. Okay, this is a damage in solar panel and rusting of the street light. Okay, then heavy weight of the entire material. Then high cost. Okay, these are the very high cost like Havels. It is supplying 45 53,000 rupees. Okay, then weather dependent because India we do not have sometime during rainy season we are not having getting sun. Okay, under calculation like here you can see that two panels are there but light is not that much sufficient. Okay, then or misleading marketing, here you can see that it is here I want to show you that can you visible like actually there's a solar street light I want to so this solar actually street light is between 2.5 to 7.5. Okay, it is 2.5 to 7.5 but marketing they are doing marketing they are telling that it is a 150 watt but actually it is a 2.5 watt. Okay, so 2.5 watt and they are selling with the name of 20 like and here okay the slide is changed no problem. So government rules are there they require for 74 watt they require 11 for 11 watt light they require 74 watt. Okay, low lumens power so increase the size is increasing the panel size. These are some problem. So possible solutions was inbuilt batteries, live solar tracking, auto cleaning of the panel, positional adjustment feature, motion detection based dimming, then unbreakable solar panel, wireless system, maintenance free system, compact design and okay, and light angle adjustment. So here you can see that from here, hide this. Here you can see that light from here morning 5:30 5 to 7 a.m. Means day okay morning and here the straight panel which is straight it is not getting the light here and after 10 you can see that after 10 we are getting the light and that is also tilted it's not direct reflecting. Okay, but here around 12 so the actual time is 11 to I can say 3 maximum or 2 or 3 11 to 2. Okay, 10 to 2 we can say 10 to 2 is actual time which is getting the maximum energy. Again that they are not getting that much energy. So we are getting the sunlight entire 12 hours or more than 12 but we are only 1 2 3 4 hours or 5 hours only getting the bright sun means actual energy. So to avoid this we need tracking. So Now some calculation. For example, 10 watt light require, for 10 watt we require 140 watts light, watt hours. So for panel we require how much panel? 70 watt panel. Active charging time will be 4 hours. So 280 watt hours. Conservation and storage loss 50% and wattage will be 140. So for getting 10 watt hour, 10 watt light, for how many hours we want to run? 10 watt hours. So that we require how much? For example, if we require for 14 hours, so we require 70 watt panel. But in, so to avoid that, we require some tracking. So how to the tracking will benefit? 10 watt light will be there and 20 watt panel will be there. Instead of 70 watt, we are supplying, means we can invent tracking that only 20 watt can manage that. So active charging time will be 12 hours. So 20 into 10, 20 watts. So conversion and storage loss will be less in efficient battery. So same energy that which 70 watt panel was giving can be generated from 20 watt panel. So size is reduced, cost is reduced. So you can see that tracking benefit, these are the benefit of tracking. More light is getting. Okay. So instead of 2.5 hours, right, we are getting how much direct sunlight? 7 hours. So 7 hour additional clear cut energy, more energy 7 hours here. At same point here only 2.5 hours. Okay. The peak. Okay, so improve oppose so solar tracking panel with street light enabling. So here you can see that instead of different component, only single component street light can work here. So these are some features. It can be the device in mobile, we can operate from the mobile. So you can see that how it is working from day to night, automatically giving light and again tracking. So instead of doing many inventions, first from a normal light to LED light, then LED light to non-integrated, then semi-integrated, then integrated, and then tracking. So better you can directly from this point to this point. Okay. So first site we successfully installed. That is also working continuously. Second site we successfully working in Shri Nitin Gadkari ji, Cabinet Minister. Okay, more than 2 years. So we installed in his house. Okay. So that news was published in Spain. Okay. So we got appreciation letter from Gadkari ji. I have not mentioned here. Okay. So then solar system with integrated dual axis. So here same invention, we need to improve it so that a street light that can track from morning to evening like this. Okay. And light can be given in any direction. Light also can be given in any direction. So that is also innovation. Okay. From season wise, if sun coming from this direction, it will tilt like this. If sun is coming from left side, it will tilt like seasonal variation is also covered. Okay. Then, so now there was one more problem was there, solar panel cleaning. So solar is also now solar farms are there, farmer side business are there. They are producing, preparing, means installing solar panels. Okay. So before you can see that dirty panel, how much energy was generating, and after cleaning, how much energy generating. So the dirtiest panel is generating more energy, 13% for so only single time, single day. So every day 13% increase means how much energy can be saved. So manual cleaning of solar panel. This is one example how that person is climbed on the panel and is cleaning solar panel. So this is very risky, not efficient. Even sometimes something happened to that labor, who will be pay for him or who will be responsible? So very risky climbing on the solar panel. Sometimes there is a chances that some people doing manual cleaning like this with the brush. That is also manually. Okay. time consuming. Some people are using spray, water, even damaging to the panels. Also, challenges of labor intensive, safety risk, inconsistent, inefficient cleaning, high water consumption, environmental impact, risk of mechanical damage to the panels and to the frame structure. Operational cost of maintenance is high, weather dependency, and scheduling the challenges are there. Okay, so then effect of rain fall on the, these are some, due to rainfall also there some problems are there. Due to temperature, we cannot do manual cleaning. Okay, then robotic cleaning are there in market. So these are some example of robotic cleaning. Okay, need to transfer from one panel row to another. Okay. So people are operating. Okay. So we can say it's not robotic cleaning. It's something like manually controlling robots. Some robots are like this. They are also available in market. So advantage of robotic cleaning, these are enhanced safety. These are many advantages was there. Okay, minimum risk of damage, scalability, water and energy efficient. But some limitations was there. So very high initial cost was there, 20 to 30 lakh rupees. Frequent maintenance required, limited suitability for existing solar installation, energy and water dependency, heavy weight handling challenges, risk of electrocution and safety concern, high water and power consumption, and cumbersome to startup and inefficient operation. So this you can see that for shifting from one location to another, manual intervention is required. So it may be damage the panel. Sometime labor can also be. You can see that labor how they are transferring from one row to another. So negative impacts was reduce efficiency, component degradation, reduce lifespan of the panels, dust accumulation. Negative impacts, clouds on robot like sunlight dependence. Some robots are running on the solar panel. Okay, types of cloud. Okay, so then disadvantages of cleaning of solar panel like high water consumption, risk of panel damage. Okay, then need of innovation. So here one need was there, innovation. So the objective two, it should work without battery. It should work automatically. It should work in all weather condition. It should cheaper than existing robot. These are some objectives there for our innovations. So normal panel, just we place the tracks, rubber tracks, and we place the this solar this wind powered solar panel cleaning robot. So here you can see that when it is coming to the end, automatically that lever pressed. So this lever end stopper is there. It is pressing the lever, and you can see that once this lever is pressed, okay, either this end or this end, it is the shifting the gears. So gears are shifted from this gear to this gear to this gear. Okay, now we are increasing the size of this turbine. So you can see that how turbine is rotating in the medium wind speed, not high wind speed. So we can say medium wind speed. So this we have installed. Now with the small wind speed also it can clean. So what will happen? It will benefit the automatic cleaning. No manual intervention required. Automatically gear will shift. It will go from one end to another end. So now people are wasting energy, their resources on already patent innovations. So already I told how. So for example, here you can see that one person have converted his Maruti van into solar driven vehicle. So that invention he have not got any patent. Similarly, one IIT Kharagpur student develop electric vehicle already there in market. Then student have prepared the electric cycle already there. All are prepared the solar by already there. What is the nothing? They will not get patent because these inventions are already electric bike in 1939. Then electric that car was 1890. Then this electric car another in 1903. Then solar powered electric driven bicycle, that is how much? 1990. Then electric car traveled by power generated by solar energy, 1995. So there are many problems. If we want to, how we can, where our innovation, where our technology is already there or not, you simply go to the Google patent, right there. For example, you have idea of solar bicycle. Just type it solar bicycle. Okay. So here you will go to Google patent. I am writing here solar bicycle, and it will give you the idea of all the patent, existing patent. Just you have to go through it. Okay. Same you can go for patent scope website, patent scope, and just type here. I am typing solar bicycle. It will give all the patent, existing patents. So now how to file the patents? Simply you have ideas, just prepare one folder, prepare three folders like for photos, then another for prior art, and another for write-up. In write-up, you have to write the form 2. In form 2, you have to write your name, address, field of invention. Then form 2, these are the titles of form 2. Okay, titles of innovation, application detail, field of invention, background, what there are advantages of existing product, detailed description, invention, advantages of your solution, main claim, field claim, abstracts, and food. Okay, then is my presentation over. Anybody want to ask any question?
Those who have questions, they can drop it in the chat box.
So meanwhile, I got some question. One was asking what is the uses of fish paneer? What is the use of fish paneer? I don't know. They want to give award to any person. Already they are fixed that they. I think they want to give award to person. It is fixed. They have given. Okay, why paneer? Why fish paneer is used? Okay. Which agriculture sector currently offering the better entry point to new entrepreneur? Any point, just you go find it, search it. That which problem? Because what the your eyes is searching, na, I cannot say. Because for example, I will say go blockchain. If you do not have any interest in blockchain, I already told the one example. Blockchain can work in seed technology. Okay, so but just I told you can use anywhere. You can go in robotics. Here I have seen, you have seen that I have prepared a robot which can work without electricity. It is 100% mechanical and only 20,000 rupees. How much cost? Only 20,000. And normal robot solar panel 20 lakhs. Only 1%. That is I am working on that. So whatever innovation you found problem, for example, your father or your grandfather or your relative or your somebody is farmer, you ask them their problem and consider it as a, and ask other farmers what they are doing, what is the possible solutions, and then you can do innovations can done on any small, might be you have seen movies. Okay, there are some movies like Mahabharat, Ramayana. It is entire long movie. And there is one example. There was one movie. I think that is Millie or somebody was there last time. Janvi Kapoor did acting. I think Millie may be there. Millie movie may be there. Okay, one, yes, Millie movie was there. Yes, Janvi Kapoor's Millie movie. Only one topic. She caught inside that cold storage. Small concept. Entire movie was prepared. So it is a depend on how seriously you take the innovative ideas or problem. Okay, you can small problem. For example, UPI transaction. Initially, it was considered as very small problem. Existing was there, bank transfer, cash was there. Chidambaram asked who, whether the vendor lady they was having, maybe having bank account or devices or like that. But nowadays, 99% people are using UPI. So initially, if you thinking it is a very small solution problem, you have to think the impact of your solution. Okay, and what is the existing solution? You have to say you can combine two or three solutions, two or three ideas, one idea to another idea. Okay, then what is the latest innovation in agriculture? I already shown now what is the latest innovations like blockchain, drones, okay, AI. Okay, then is there your patent solar panel commercially available? Okay. They are commercially soon will be available because it is an R&D. It is require continuous process of improvement, reducing the size, increasing the energy, okay, reducing the motor size, reducing the gearbox size. It is continuous innovations. Can you share the PPT? Okay, I will. Okay. Shelf life of solar panel for household purpose. Sir, shelf life company, what is the company is giving, from which company you are preparing one first grade or second grade, China, made in China, made in India, like that it depend. I cannot guarantee that what is the shelf life. Some people say China means chale to chand tak nahi to raat tak. Might be tomorrow you may not work, or it will work for 25 years, I don't know. So it is not, it depend on where, from where you purchase. Can solar panel store enough energy to use in winter season when so light is 1 minute. Light. It is so light. So light is light. I'm not have solar sunlight is in winter there will be enough sunlight. Light problem is only during cloudy. Even during winter you are getting more clear light compared to summer, because summer monsoon is sometimes it is called as summer monsoon. Okay, because in winter we are getting light, clear sky and light which are less warm. Though time duration is less, but most important problem is during cloudy days. And cloud start from May itself. So, and up to March, sometime cold is there. So only April, May, that is only small sun period is there. So I cannot say that during winter, problem is during cloud, some means winter, sorry, rainy season. Anybody want any question? Any question is left? Students, participants? So somebody saying that so solar panels are working on light availability. Yes, that is the main concept. Solar panel means that's only light required. Yes, right. Yes. During rainy season, what is the escape? What is the escape means you are asking the solutions. During rainy season, tracking is one of the best benefit. Second, storing the energy from long hours. Instead of full 12 hours, we require 48 hours. Okay. What light is essential, solar light or electric? What light is essential? Please clear the question. What light is essential means solar light or which light you are asking? Listen, solar light or electric? Electric is general means consuming the energy, and solar is without energy. They are consuming where the sun solar light can fix. So two problem was there in solar lighting was there, big size panel was there, 70-watt panel, and the battery problems. That's the problem I am solving. Okay, electric light, that is they are also having problem like stealing of the light, stealing of the okay. So what is the success rate of solar panel in the areas where winter is more severe, like the innovation panel and make work in this area. Success rate means already European countries they are using the solar panel. Success rate means I cannot say that solar is always success, but the places which are getting less light, they will get less. It's a some simple logic. Number of bright sunshine hours are less, solar panel will not work. It's not like that my place is here, my place is there. Simply, even northeast states, they are continuously cloudy weather is there. Such places, solar panel cannot work. The places where some like industries where carbon is coming out continuously, solar panel carbon is or dust is accumulating. There, solar panel not work. So does not matter where you are from in Kanyakumari or you are in Kashmir. Entirely depend on bright sunshine hours. Due to tracking, we can utilize these hours better way. Okay. And during cloudy, if tracking is there, for example, from morning 6 to 10, you got sun. From 10 to 2, cloudy. Again, from 2 to 6, clear sky. That time tracking will benefit. Okay. Any question? Any question? I hope I have answered many questions. Okay, thank you.
Okay, thank you, sir, for your insightful and enlightening session. And you clearly explained like everything and how these innovations are like helping farmers as well as the livelihood of India. And we truly appreciate your time and your expertise. And it was pleasure having you here with us today. So, I sincerely thank each one of you for your active participation, thoughtful interaction, and enthusiastic presence throughout the session. Your energy, curiosity, and eagerness to learn everything like the new topics was amazing, making this session not only engaging but also highly impactful. Each question, discussion, and shared perspective has added tremendous value, fostering a vibrant learning environment. We extend our heartfelt gratitude to our esteemed speaker who joined us today from their busy schedules, and all the participants for contributing so meaningfully to the success of yet another productive enlightening day. As we move forward, let us continue with some spirit of enthusiasm, positivity, and dedication. May the knowledge gained and the connection made today inspire innovation, thinking, and collaborative action in your respective fields. We eagerly look forward to your continuous participation in upcoming sessions as per the program schedule. And thank you once again for being such a wonderful and engaging audience. Have a pleasant evening and stay motivated, and see you soon in the next session.